Okay, thanks, Brian, and hi guys. I thought what I'd do is give you a very quick summary tour of what this method's all about, and then get as quickly as possible to what the tool actually does. So this this tool, this approach, this method is all about dealing with dynamic challenges, is how things change over time. So it could be a functional thing like dealing with staff turnover, or how are we going to deal with a falling sales rate, or what can we do about raising quality, improving cash flow, cutting new product lead times, growing company profits, and so on and so on. And what these cases have in common, and all the strategy cases we deal with, is that there is usually some history of kind of how we've got to where we are. And there's a fear that things could get worse, but what we want is things to get better, but that's not going to happen overnight. So there's all kinds of versions of this, but that's what system dynamics does. It deals with how things change over time and gives us a way of modeling that. So here's our kind of generic starting point. Really, whatever the question is we're dealing with, we'll look at it through this lens. So we specify the desired performance over time. What we do is we identify why that is happening by linking that performance to changes in things we call resources, and they're quite specifically defined in strategy terms and quantified. Then these things have got a particular characteristic, which is they accumulate over time, and they depend upon each other for that to happen. So we look at the impact of that interdependence and the impact of decisions as well. And when you put all that together, what you end up with is a working system diagram and model of how a business works, or a function works, or an issue works, and from that you can figure out what actions and decisions to take to get improved performance. And there's a load of extra extensions you can put around that to deal with all kinds of different things that crop up in many different situations. We haven't got time to go into those today, but that's just to say that what I'll show you is the very simple core of the thing, but just to bear in mind there are these other things you can do too. So I thought I'd just give you a very simple example we use in the course, and this is an example. If you look at the thing up in the top right there, it says you can use the method for dealing with an overall plan or for a specific issue. You can use it for a whole organization or for a department or function. So this is an example of a specific issue faced by a whole organization, and it concerns an IT support provider. And the history of this is that they took on a business development guy who signed up lots of clients. The client support staff got overloaded, quality of support suffered, clients left. And at the point we kind of were looking at the situation, the worry was that the business would basically kind of fall apart following the red line, and we wanted a way to kind of get it back on its feet and follow the green line. So the risk is, you get more staff losses, still worse science service, even more clients leaving, and so on. I'm sure the story won't be unfamiliar to you guys. That this does happen. So if we want to understand this, we start with what the performance thing is, and it's that problems per month that our clients are facing over on the right, and that's a certain numerical value. We figure that comes from the pressure our staff are under, and that's a factor that depends on how much support is needed compared with how much the staff can actually do. And that support need comes from the number of clients we have and the hours per month of support that those clients need. And the available hours comes from the number of staff we've got and the number of hours they work. So I said earlier on that we define these resource things very carefully and very precisely. That's what I mean, right? Resources are clients or customers driving demand, staff providing service capacity. In this case, there could be a product range involved, there could be physical capacity involved. Cash is one of these resources. So here's our second principle. The first one is that we worry about performance over time. The second principle is that it's resources, these stocks of things that drive that performance at all points in time. So here now is an extract from the working model that shows this for this particular company, and there's the performance over time for the problems increasing up to month 24. There's the pressure on staff, and the blue is following the history up to date, and the red is showing where we might go. That comes from this balance between demand and supply, and you can see that gap opened up with too much demand from about month 6, and it's just been staying worse and worse over the latest 18 months or so. And I've just put them on the same scale so you can see what's going on. And there is what's happened to the number of clients and the number of staff. So clients peaked, staff started leaving soon before the clients peaked, and the red line shows the kind of adverse future that we don't really want. So this table is a table of these standard tangible resources you find in all kinds of different cases. If you're looking at a manufacturing company, you'd have customers, machines, staff, products. If you were looking over to the right at a law firm, you'd have clients. Lawyers are both staff and capacity for a law firm. They offer a range of services and so on. So it's a pretty standard set of things that applies to all kinds of different cases. Now the principle that makes this all work is this idea of an accumulating stock, and we all are pretty familiar with this because this is what our bank balance does. Our bank balance accumulates because more cash goes in than comes out, or it depletes if more cash goes out than comes in. So this is the iconography we use. The box is the stock. The thing on the left you can think of as a pipe with a pump on it, and what we want to know is what drives that pump at that rate, and what can we do to make that pump run at the rate we want it to run rather than a less good rate. So that's basically our central tool, and in all of this, these flow rates are absolutely critical. Everything we do, all the strategy cases we look at, it's all about the flow rates. Customers won, customers lost, products launched, products lost, discontinued, staff hired, promoted, staff fired, staff who leave, staff turnover, and so on. And the principle is quite simple. If performance depends on the stocks and the stocks don't change, then performance doesn't change. So the only thing that can change performance is the flow rates that alter the stocks of things. So here's how that principle works for the IT company. If you look on the left-hand side here, they won lots of clients, so the client base started growing, but then the win rate fell away and the loss rate started to escalate, which is why the client base has come down again. Oh, that's just what that says. And you could do this in a spreadsheet. It would drive you nuts before very long if you tried, but it can in principle be done in a spreadsheet, and the table on the right simply shows what would be in that spreadsheet if you did it that way. So now we come to the impact on performance. So there's the clients at the top, and that's giving rise to that chart at bottom left of how many service hours per month are involved. And if you look at the total service hours, it comes from the hours you need to bring on new clients as well as the hours you need to service the clients you've got. Down at the bottom you've got the staff hours per month that are available, and that's where the pressure on staff comes from. And this was such a severe situation that there was a rather severe conclusion reached by the client, by the company here, and that is that they would actually deliberately, on purpose, discontinue some of the remaining clients because they simply couldn't cope. There was no way they could continue giving adequate service to all the clients that remained. Not many cases are quite as severe as that, but that's what was right in this case. Same applies to staff hired and lost. You've got the hiring rate on the left, you've got the loss rate on the right, and that's why the staff numbers change over time as it does. And we put it all together, we get these interrelationships between these things. And what the software does is that the software actually enables you to implement this. So I'll launch that and get that in the window as well. Will that go there? No, it won't. Oh, yes, it will. There we go. Cool. and I can go full, I should be able to go full screen on that. There we go, excellent. All right. So this is the modeling tool that does this, and the state this is in it's in a read-only state. So you can send this model to people and they can play it themselves. So you can reset the model, start it from the beginning, play it for a while, see what happens if you change the hiring rate. You know, you can see further down in the model here. You can see the pressure on staff beginning to build up there. So if management was on top of this, they'd be watching that. They'd say, hey, pressure on staff is building up. What they should have done, of course, is slow down the client acquisition while their staff caught up, but they haven't done that. So maybe they think they can fix it by hiring more staff. Maybe they should hire even more than that. So let's play for a little while longer. And yeah, okay, so we've managed to improve things by some pretty radical changes to the hiring rate in the business, but you get a different result if you did it at a different time. So that's the kind of model you end up with, and if you go to the link on this, you might just take a note of this, or Brian can share it with you. It's that link at the bottom right there, sdl.re/m4a03. That will open up that model. And you can just play it yourself and see what it does. When you're in that model, you'll see up here there's a little tour. It's a little video, not video so much as a screencast tour that kind of takes you through the stages of how these models get built. And the help system is also organised around the process of building a model from first principles. So that's the method. That's what the software does, and we can go to kind of very much more complicated things than this, and it works in all kinds of different situations. I'm currently doing some work on modelling poverty in the UK. I've got another project on at the moment modelling the development of a whole business sector for a developing country. So we're looking at how the transport and road system in Nepal develops over a kind of 20-year time horizon, and the different policy choices that governments and aid agencies could deploy to make a difference there. Oh. Okay, well the automation tools you've got is one of these stocks of accumulating things. Okay, so you would have you see the structure here with the clients and new clients there. You have a stock of tools, and you would look up from that stock the difference that would make to the productivity of your people. Okay, so for every extra tool you add, you expect that it will have a certain fractional or percentage impact on reducing the staff hours per client support requirement. So this thing down here, the service hours per month for current clients, instead of being a constant, that would be a variable that depends on the accumulating stock. We've got several examples where we've done exactly that. That's a very common thing to do in service-oriented cases. Is that answering your question, Jeff, or do you want me to say a bit more about that? If you have the potential to automate a process completely, then you can have a structure here which looks at clients and the work that they and the support that they need being provided in the first instance by professional staff, by IT specialists, and you can have a but shall I just show you this? Why don't I show you? That would be the thing to do, wouldn't it? So let me zoom in a bit, give you a better view of that. So that is clients with staff support, and let's say we start with 1,000 of those, and we've got here a stock of clients with auto support, and that starts at 0. And we've got a flow rate going on between these things, which is client automated per month, and we have a stock down here, which is so as time goes by, your automation is able to automate more and more of what the clients want, right? So that starts off at, we can start that off at some kind of modest level, and as time goes by, then it's so that there is the rate at which our automation capability is increasing. To do this properly, you would actually have a stock which is the automation tools themselves, and you would look up this applicability of the automation from the stock of tools that you're building. But what that does is that drives this rate here, and so that right there might be clients. So as this automation level increases, you can automate more and more, either more and more of the clients, or more likely it would not be so much the stock of clients as the stock of client applications or client needs that would be automated. And you can see from there that it's dead easy to just change the parameters in this, and I'm taking a 1/10 view there, so maybe rather than 1/10 it's 1/5. So to actually build this model for that particular challenge, you would populate the model with the actual data on what had happened to these numbers over time, and you can kind of sketch in what's actually happened to this thing, and you can sketch in what you think has happened to your automation levels. So you've constantly got both the real data on what has actually happened, and your forecast data on what you would like to happen. Let's say, whoa, you don't want that. You'd want that to go up faster and stay up, right? And you're comparing it constantly with what the simulation is telling you would be happening. In terms of the process by which you get people to this, that is exactly what you do. You draw this diagram up on the whiteboard, you get them to sketch in what they think has been happening and what they would like to see happen, and then you can build these models live with the audience while they're sketching it on the whiteboard, and produce a living version of what they've just sketched in real time. We developed this tool because the existing softwares that do system dynamics are too heavyweight and slow and hard to use. So this was designed to be with ease of use, to kind of front of mind, so you can get things done really fast. We built a demonstration model like that with a team from the Bank of England recently on the issue being how vulnerable is the UK banking system to failures in the settlement systems between the banks. So we sketched out an example of the structure that would make that happen. We sketched it out on the whiteboard, and while I was sketching it, my friend was building it in the software. So after 45 minutes, we gave them a working model of what they'd just put up on the whiteboard. Would be you'd have a somewhat similar structure. You'd have clients or customers who were taking your bought services, and clients who are on the other side taking your recurring revenue services. And in the middle, there could be a stock of clients who are taking a mix of both. If you've got multiple things that you're selling to the same customer, which I guess you have. Um, so if you're looking at your whole product and service delivery picture, then it would look like this. You could also have a model which is looking at the products and services that specific clients are taking. So you're looking at the migration of the service provision for a single client, which starts being, they're taking 50 services from us and they're all bought and paid for on the one hand. And on the other hand, we want to move them to a situation where they've actually taking not 50 but 70 services that are on a recurring revenue basis. And you can model the migration of the services you're providing to them from the state on the left to the state on the right. I guess there are a couple of things you would want to know about that. You would want to know, for example, how much cost and effort would have to go into getting them to move one of the services from bought to recurring revenue. You'd want to look at the revenue streams from the two sides of the solution population and add that up, and then look at the kind of ROI thing that would emerge from doing that to your client. Of course, the other thing you could do is you could actually do that for the client. You could say, here's what you, Mr. Client, are getting from us at the moment. Here's what it's costing and here's what its benefits are to you. If you migrate with us in the way we would like you to do, here is the difference it would make to your business. Here is the changes in the benefits you would gain from using our services, and here are the changes to the costs that you would incur from rather than buying the thing from us and paying a support fee. Here's what you would be paying if you did it on a recurring fee basis. This is a change that's taking place in the IT outsourcing world, where IT outsource providers are moving from providing a service of actually kind of looking after the people and the kit and the apps to saying, well, why don't you, client, forget about worrying about all of that. We will just provide you with an application and you pay us for that. So if I zoom right out here, what we've got on the left in the yellow area is we've got traditional contracts that are in decline, and some of them are being renewed, but a lot of them are being lost to low-cost competitors like Infosys and people like that from India. And the structure down below just maps out what happens to the people and the kit and the cash flow from that style of business. What we've got on the right-hand side is the application provision business with in the kind of upper middle area here, you've got the client population migrating from the stuff on the left to the stuff on the right. And if I zoom in again, what we have here is this is what's happening to the change in the mix of revenue streams from the two lines of business as a result of the policies that we're following here. Now, what's tricky here is that the people and the stuff that you need in the yellow area for the old style things you do is not the same as the stuff you need on the right hand side to offer this business application provision service. You need developers to develop the applications, you need salespeople with different kinds of sales skills, you need different kinds of support folk than the kind that you've got. So what this business has to do is wind down the stuff in the yellow area on the left and wind up the stuff on the right, and kind of not drop the balls on the way through in doing that. So this is an example of the kind of strategic transition I think you were referring to. This whole field has got a very, very long history. It was developed at MIT in the 1960s. What it is engineering control theory applied to social systems. That's essentially all it is. And its adoption has been frustratingly slow for most of those 50 years. And there's a couple of reasons for that. One is that people are very wedded to their spreadsheet tools and think that they're perfectly okay for their issues, and that they're clearly not, but they believe they are. The second is that I've given you a very, very quick introduction to all this. To learn to do it is not trivial. This is not an easy thing to do. It's easy enough to use the software, but actually figuring out what it is the software ought to be being asked to do is not as simple as I've made it look, perhaps. So the introduction I gave is basically my attempt to simplify that so that people can kind of get it and adopt it. So the end result of all that is that the method has been picked up and used very strongly in certain areas. So supply chain, project management, pharmaceutical product development. It's beginning to be used quite extensively in FMCG market planning. So Coca-Cola uses this for its global marketing strategies now, brand strategies. So my sense is that we're on the cusp of the adoption starting to take off, and there are a few of us trying to do some things that will help with that. My contribution is to make the method understandable by people who are not people with PhDs in computer science. And that involves both the presentational approach to it, which I showed in the slides at the beginning, and the software tools that ordinary people can use without going nuts. That's my contribution. A colleague is making a rather different kind of contribution, which is that he's basically given up on the idea that we are going to get every analyst in every corporation worldwide to switch over from Excel to this. And he's going straight in at the top and saying, we can solve your problems. And you don't need to worry about this, Mr. CEO. You don't need to worry about the fact that your analysts can't do it. We can do it for you and solve your problems. So if you go to simudyne.com, SIMUDYNE, simudyne.com. Yeah, it's up on screen now. So as you can see there, their kind of buzz phrase is engineering reality. And what he does is he takes these models and he puts real easy user interfaces on them and hands it over and says, look, here's the model for you to fix your problem. And he does it not only with these business applications, but he does it with some of these 3D virtual reality things as well. He's a very engaging but relatively pushy Texan. No offense to any Texans who might be online here, but he says things as he sees them, and he's quite happy to say to CEOs, we have the method and the technology to simulate every significant decision you now need to make. If you're not doing it, you are being irresponsible, and you should be fired. This is one taken from a project I did with a corporate law firm several years ago now. It concerns the staff pipeline of lawyers moving up through a law firm. Now, you go from trainees down the bottom to lawyers in the middle and partners at the top, and it works the same way. You play the thing and make some decisions about hiring, and let's hire a few more lawyers from outside because we can't get the numbers that we want. And that seems to hit our objective here in the middle, to get 150 odd lawyers by the end of the period. But you could build that model with the actual numbers of people in all of the stages of seniority, and you can replicate the model across functions. So you can have this pipeline for product development people, for sales people, for operations people, for customer support people. You can use that for planning forward on staffing policies. So you could build a model like this where you've got raw trainees, you've got trained trainees who are then competent, and your tool would be altering the rate at which people move from here to here, and the speed of that, and that would come at some cost. You could factor into it the cost of things like trainee turnover during the period when they're being trained. They get fed up sitting in training for weeks on end, so the attrition rate's quite high. That would go down if you used your tool. What would happen if the attrition rate went down from 20% to 15%, all that kind of thing. So yeah, you could definitely use it in consultative selling in that kind of way. In fact, for that kind of quite focused solution proposition, that's actually pretty easy to do. You can configure this to the generic kind of situation, and then it's a matter of, well, I wouldn't say minutes, but not many hours to reconfigure the model to look like the client's business. A company that is doing that right now is Nokia, and this is not the sick part of the Nokia business, the old handset business that's failing. It's the network equipment part of their business, where they are able to help cell phone providers plan, monitor, and change their subscriber propositions and flex those in response to real-time information about how those subscribers are responding to those propositions. Just before we wrap up, I guess we're kind of running out of time here. We do run an online course on this, but we're doing introductory winter school in the first week of January, January 6th to the 10th, and that'll take people through, in summary, the main parts of the method, and it'll be online with kind of webinar support. So if you know anyone who might like to get a little bit more familiar with how this works, that's an option for you all.